Rendering performant lists has always been a pain point in React Native. The default tool, FlatList, works fine until your item gets more complex, then you start running into its limitations. Back in 2017, RecyclerListView introduced view recycling for better performance, but it required fixed item sizes and wasn't easy to adopt. In early 2022, Margello, a high-end app development agency, announced WishList, a native C++ list that promised to change the game, but it never made it to production. Around the same time, Shopify released FlashList, with dynamic item size support, 60 FPS scrolling, and a drop-in API for FlatList. It solved many problems, but lacked maintainVisibleContentPosition, limiting use in Chat UIs. It also depends on native code, making supporting other platforms such as macOS, Windows, and Vision OS difficult. In late 2024, Jay Maestrich released LegendList, a list that is built for performance, supports dynamic item size, drop-in API for FlatList, written entirely in JavaScript, requiring no native code, supports bidirectional lists and chat UIs without hacks for inversion as well as maintaining item positions. Let's look at 4 examples to see how it performs in practice. The first example we're going to take a look at is performance. Now, LegendList claims to be built from the ground up for performance. So let's put that to the test. In this example, I have a list which renders a list of posts. That's how the screen looks like. So initially I'm using a flat list, and then we're going to compare it with LegendList to see how performance benefits that we get. So it's basically a flat list. We pass it this data, which is an array of 1,000 items. It gets a random number, from 0 to 4, and then it gets one of 5 random posts, basically. And then we have this render item, which just renders this list item, which just have a bunch of views and stuff to get this UI that you see here on the right. So let's go ahead and scroll kind of quickly and see how FlatList performs. Now, as you can see, initially a lot of items loaded, so we were able to scroll a lot, but later we hit a scroll block, right? So as you can see, I reached the end, and then we can't scroll anymore, and then more items need to be loaded, and then they load, and then we can scroll, which is not a very good user experience. But what's even worse is that after a lot of items have already loaded, if I try to go fast really up, now let's see what happens. As you see, I start to hit a lot of blank spaces, which is not ideal if I'm being honest. You see, now it's only blank space. I do have to say that I'm using a low performance Android emulator here. I configured it to be low performance, just to make sure that the testing is obvious. The other thing that we can see is that in the console, we get this really, really ugly warning, which if you've been working with React Native for a long period of time, you must have hit this and try to search for it and see a lot of people also complaining about it. And it's you have a large list that's slow to update. Make sure your render item function renders a component that follow React performance best practices like pure component, should component update, blah, 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 which even if you do all of this, you still get this warning, which is just annoying. So with that, we saw how it is with the FlatList. Let's go ahead and migrate it to LegendList. The first thing that we obviously need to do is we need to add LegendList to our list of dependencies. So I'm going to do bun add at legendapp/list. And with that done, let's go ahead and start the app again. And let me just reload here the app. All right, so what's the migration looks like? It's super easy, guys. It's supposed to be a drop-in replacement, so we just need to, let me go ahead and import that. LegendList from LegendList, and then it's literally just doing that. Now we do get an error here, but it's just a TypeScript error, so let's go ahead and update it. It's just that this list render item info should be LegendList render item props, and the same thing here. It's just a TypeScript thing. Well, with this done, let's go ahead and see how the performance is, right? It's built for performance, so let's check it. Well, I mean, we see a lot of blank spaces, I would say. So we don't see scroll blocks like we were seeing with FlatList, but it's not really good. Now, to be honest, LegendList has a guide on how to optimize for performance. So let's go ahead and use these techniques, right? So the first one would be recycle items. So what this prop does is that instead of creating destroying items that go out of the view and then creating new ones, which is expensive, it would reuse the one that went out of the view and use them to render the new ones. So that's recycle items. The other one is estimated item size. You can give it an estimation of what's the size of the item, but this is mainly to reduce layout shifts, which I don't think is important in our case, but let's do it just anyway. And the other one is key extractor, and that is when an item's layout has been calculated and the data changes, so like items need to be reordered or whatever, instead of recalculating its layout, it would reuse it. But again, we're not changing the data here, but let's do it anyway. One more would be draw distance, which is the amount of distance that's being drawn outside of the viewport, like kind of to allow as you scroll so that items are being rendered and you don't see a blank list, like an empty white blanks, right? So for that, I can do dimensions dot get window and then do height. So with this, basically, I'm saying render an extra height of the window below the current list so that as I scroll, items are there, right? So with these optimizations in place, let's go ahead and see how it performs. I hope it's better. Well, I mean, if I scroll normally like a normal human, I would say it's pretty good. If I go really crazy, I would say it's pretty good, guys. There is no this huge blank spaces like it was with FlatList. So I would say that's a really good win, right? On a very low performance Android device. So I'd take that, honestly, that's really good. Well, performance is nice, but remember we used recycle items and recycling has caveats. So for example, in this list item, I have this state where if someone would like this post, it would show this heart as filled and it would increment. Now let's go ahead and scroll a bit here down. As you can see, this is the heart here is filled and it's 3. But if we check our data where it says Nina Patel, you'd see that the likes count is 2. So because the items are being recycled, so does the local state, which is really bad, right? You don't want a state from a previous item affect the state of another item. Luckily though, LegendList provides us with hooks to work around that. So instead of using use state, what we can do is we can use use recycled state, right? And then we would use it almost the same way. So let's go ahead, let's go back in here again. So let's hit this like button and then go down, right? So as you can see, guys, all of them has their hearts unfilled, which means the state is not being recycled. It is also important to note that there's a use recycling effect, and that's basically when if you want to reset some state because an item is being recycled, you can use this hook, which will call whatever callback you pass it, right? So you go ahead here and you define a function, and when an item is being recycled and you want to do some resetting logic, you can do it here. Let's look at another common use case for lists, and that's scrolling to a specific item. In my opinion, in a lot of apps, for example, e-commerce and stuff like that, like you would need to navigate a user to a specific item when they press on a specific category or a specific product, and then you need to scroll to it, or even not e-commerce. I've honestly encountered this a lot of times in my career. So that's what this example is about. The UI looks almost the same as the previous example, except that we have this here, a text input, right? This empty space here, and then a button. And the idea is that I will enter here like an index, so like 32, and then I press scroll, and it should scroll me to that specific index. Now, the way that this works code-wise is that, again, we are using a FlatList as a reference point. And then we are creating here this ref, right, to be able to control this FlatList. And we pass it as a prop. And we have this method here, on scroll to index. So this is being passed to this item index input, right? So there's this text input, and then when we press the button, we call this onScrollToIndex. And what this does basically just calls scroll-to-index, which is method on FlatList, right? We pass it the index with animate true. So basically, this is index 32, go to the 32 with index 32. So let's go ahead and try it with 5, right? Initially, to scroll. As you can see, it goes to the sixth item, right? Like index 5, so it's the sixth item. Now that's really nice, cool, right? So let's go ahead and do 300. Let's be here optimistic, and it seems to be work. So we get this error, which is scroll to index should be used in conjunction with get item layout or on scroll to index failed. Now let me explain to you what's happening here. The problem is that we're telling FlatList go to item 300, but item 300 hasn't been rendered yet. And FlatList doesn't know how much it needs to scroll down in order to get to this item 300. Now the solution that it's telling us to do is provide a get item layout. And basically with this, we tell FlatList how big our items are, right? So in this case, our height, for example. So we say our item is 100 points high, and this way it's able to calculate how much it needs to scroll to reach item 300. Now the problem is that this is not really realistic, or like in most apps you can't do that because items are of different sizes, right? So if we check, for example, here, it could be that this post have more text than this one, and then the name here wraps on 2 lines, so we can't really tell this get item layout what's the height of our item. So we can do that, and as a result, we can't really implement this implementation, which is really bad unless we provide fixed item sizes. So again, let's take this example and migrate it to LegendList and see if it can do that. So again, let's go here and replace FlatList with LegendList and fix our, now what we need to do is basically fix TypeScript errors. So technically it works, but again, LegendList render item props, import, and then LegendList render item props. And then here the type of the ref is also wrong because it's not really a FlatList, it's a LegendList ref. So just like that, guys, we migrated it to LegendList. Let's go ahead and try it. So scroll to nth item. Let's start with 5. Scroll, works amazing. Let's go and do 300. And oh shit, it's 154 again. No, not there yet. No, let's go one more. No, yeah, we're close. Now we're at 300. So even with LegendList, it doesn't really work well. Well, that's what I thought until I created an issue on the repo, and the maintainer Jay had to let me know that I need to add a prop. Now it's not very obvious. Now it is maintainVisibleContentPosition. It's not obvious that you need to add this to make scrolling to a specific item work, but it's just an implementation detail, and the maintainer Jay mentioned that it is possible that in the future you will no longer be needing this prop when scrolling, but for now you need it. So let's go ahead and check it again. So 5 scrolls nicely, 300, and here's 300. So that's really nice, guys. It's a really common use case, and it's really good that you can use LegendList to implement this functionality. Let's jump into the next example, and that is Chat UIs. Given LegendList's performance and its ability to scroll to a specific item, it makes it a very strong candidate to build Chat UIs with it. Imagine a WhatsApp or a Discord. They always allow you to be able to click on, for example, if a message was replied to, you can click on the reply to message and it scrolls you all the way there. So it's very common in chat applications. But I already showed you performance and scrolling to a specific item. I would like to highlight some other stuff when it comes to Chat UIs. So again, as you can see, this is the example here. I have a view, and then this is the FlatList, and then there's an input where you can enter something. So let me go ahead and try that. So I'll just add in hey and then send it. And as you can see, this is the message. It works fine. Now, but the problem, I find 2 problems with FlatList in my opinion. And that is the way that the inversion happens. So usually when you want to create a chat UI, you use this inverted prop, right? Because you want to scroll, you want items to start at the bottom and scroll up, right? Usual FlatList or scroll views, you start at the top and scroll down. So you would need to use this inverted prop. But the problem is that there's this functionality in iOS where you can tap the status bar, right? And the common thing is when you tap the status bar, the list would scroll to the top in the up direction to the top, right? And this is very convenient in Chat UIs where you want to go up in history. I use it myself a lot, so I would just tap up here and it would just go up. Now the problem, the way that FlatList inversion is implemented is that kind of the list is inverted, literally flipped all the way around, right? So if I'm at the top and then I tap on the status bar, it scrolls me to the bottom, right? To the which is the beginning of the chat. But that's really not an intuitive thing for iOS users. Now, this is more UX, but DX, in my opinion, developer experience is that the way that you need to provide the data to the FlatList is unintuitive, in my opinion. So the way that I would see data being passed to the FlatList is that it would be an array, right? Where the first message is like the earliest message, right? Like this is the first message, this is the second, and then this is the most recent, and then all the way, which is the one that is like the most recent, for example, this one, that could be it. So this is it. That's how you would expect things to be flowing, right? Like from the old to the new. The same way that the data is being represented here, you would like to see it here. But the problem is, again, how inversion is being implemented in FlatList. In FlatList, you would have to invert your data. So as you can see, here's my state. I'm taking my initial data and then I'm reversing it. When we want to send a message, so as you can see, I have this one, let me see. I have this method here, which sends the message. So basically I want to add it to this array. The way that you would usually do it, or intuitively, is you would just push, right? Or like append it at the end of the array, but not with FlatList. You would have to put it at the beginning. And that's also not very good for performance, because when you add items to the beginning of the array, you'd have to push all of the other elements one step forward. And that's usually less performant than just putting one item at the end. So let's see if LegendList does better in these kind of things. So you already know it by now. Replace FlatList with LegendList, and then fix the TypeScript issues. So props, and then again here it is LegendList and your item props. And then we would get this error here for the inverted, and that's because LegendList does not implement inversion using this prop. Instead, we have to use 3 props. The first one is align items at end. And what this does is basically it stacks item starting from the bottom, right? And then we would need to use an initial scroll index. So basically we want to tell it to start from the last message. So like scroll all the way to the end. And that would be initial data. So let's get the index of the last message dot length -1. And the last one would be maintain scroll at end. Now with all 3 of these props, what we're saying basically is start stacking items from the bottom, maintain the scroll position at the end, so that when you open the keyboard or more items start, like if you add more items, it stays at the end. And basically we're telling it to be scrolled all the way to the bottom. So let's go ahead and check out the example now. Now, as you can see, we lost some styling here, like padding and gaps. But this is really not LegendList specific. It's just because I'm using native Win here and it doesn't know really how to style like the LegendList. So I'll just add it manually. So padding is 8 and then gap is 12. Let me go back, save, and then come back. So this is content container style. Let me comment this one. Let me go back and here again. So as you can see, now it works fine. Now, again, the messages do not appear well. As you can see here, hey, are you free to talk now? This is the first message, so it needs to be all the way at the top. But that's because we were working around with the issue of FlatList, right? We were reversing the data. Now, the nice thing is that you don't need to do that with LegendList because it renders items intuitively, right? So if you scroll all the way to the top, and then we see here the messages, hey, are you free to talk now? It's the first message. So you don't have to reverse the data. And when we want to send a new message, we don't have to append it. We can just push right? So we can basically, sorry, we don't have to pre-append it, we can append it or like push it at the end. So let's go ahead and try sending a message just to make sure that also works fine. As you can see here, it works well. Now, one thing that I want to try is the status bar thing, right? So if I tap the status bar here, as you can see, it scrolls to the top. So it fixed both problems. The UX problem, now if I tap on the status bar, it scrolls me to the top. The other thing is the order of data. You would just pass it as you would intuitively have the data. So it's clean, intuitive, and works just like a proper chat would, with a nice performance and benefits like you get with scrolling to a specific item that's not even rendered yet. Another feature that LegendList claims to support is bidirectional infinite lists. Now, bidirectional infinite lists are lists that can continuously scroll in either direction, top or bottom, infinitely as the user scrolls. Now, if I'm being honest, I've seen a lot of requests for this functionality on GitHub issues, Stack Overflow, or Reddit. It's a hard to get feature. Now, what use case could be for something like this? A use case would be a calendar or a timeline. Think of a UI that you can continuously go forward or backward. So with a calendar, you can usually focus on the current time, and then a user could continuously look into the future or go back into the past. Let's take a look at the example that we have here. This list has an array of 12 items, and this is the initial data. And then for each item, I get the current year and then the index for the month. So basically, it shows 12 months starting from January to December of the current year. And then each item is being rendered using this box with a different color for each month. Of course, to start with, we're using FlatList as our base reference here. Now, in order to be able to scroll to the current month, in my case now is May, we would have to use the initial scroll index. Now, initial scroll index give us the same limitations that scroll to index was enforcing on us previously in the previous example. In order to support that, we had to provide the get item layout. So if we take a look at the get item layout function, we see that we need to provide the length. And when we need to provide the length, that means we need to kind of give a fixed height to the items. So this is already the first setback. That aside, let's check out what it looks like when I scroll down. Now, if I go to the end, you see that I have this loading indicator, and then I'm able to scroll more. And then I get this loading indicator, and then more data is being loaded. Now, the way that this is implemented is with onEndReached. There is such a prop on FlatList, which you can provide it a callback as you approach the end. And what I'm doing here is that I'm grabbing the last date that I have, and then I'm preparing the next data, which is a list of 10 items where each item is 1 month ahead of the last date. And then I set an isLoading state to true, and then I give I call a set timeout with a 2-second delay, and then I set the data. After that, I set the loading to false. Now, the reason for this set is loading next data is so that we use it in the list footer component, which shows this activity indicator or loading indicator that you see at the end. So if we're loading next data, we want it to animate or be visible. Otherwise, I want it to be hidden. Now, awesome, that seems to be working perfectly. Let's go to the top and see if it works scrolling upwards. As you can see, it does not load more data. And the reason for that is that I'm not providing any kind of logic. There is no onStartReached here. To press it a callback, that would invoke some logic as I scroll to the top. However, we can implement some workarounds. There is an onScroll event here, or like prop that we can provide, and it provides us an scroll event. So every time we scroll, it provides us the event. So what we can do is that we can know when the user is at the top from this event, and then implement our logic where we add more items. However, I would say this is very error prone and it's hard to get right, and it's a very manual approach. Now, the other solution would be to use the refreshing or refresh control, and that's what these props provide you is this pull down to refresh, when you're at the top and then you pull down and you get this loading indicator, and then like items load. Now, the problem with this solution is that it's not intuitive. This is not the user expected behavior. For bidirectional infinite scroll, it's expected that as you reach the end, then more items are loaded. The scroll down to refresh is more to refresh the data and not to add more data to the top. So again, let's go ahead and convert this to a legend list and see if this fixes if our problems are fixed. So again, replace FlatList with LegendList, update the types of render item, and also for list item. Now, as you can see, we also have an error for maintainVisibleContentPosition, and this prop is being used so that when you're at the bottom and you need the items to load, you need it to stay where it is and maintain its scroll position instead of jumping down, or also at the top when you add more items to the top, you don't want it to jump. However, the implementation for it with LegendList is not an object, but just a Boolean. So we're just telling it to maintain its position. And then the other thing is that get item layout is actually no longer in LegendList supports scrolling to a specific index, even if the height or the size of the item is unknown. So we can get rid of that. Let's remove that. So with that, our FlashList migration should be done. Let's go ahead and try and scroll down. It seems to be working nicely. Nice. Now let's go ahead and implement scrolling up. Conveniently, LegendList provides us with an onStart reached. So we can go ahead and copy these and then replace onEndReached with onStart reached. And then instead of onEndReached, I will also use a callback that I have, which is called onStart reached. Let's quickly take a look on that. Oh, I call it onTop reached. So let's go ahead and I can actually rename it just to match the prop. So onStart reached. Let's take a look at that. It's almost the same as the onEndReached. So I get what instead of getting the last date, I get the first date, and then I set up 10 dates before the first dates instead of after the last date, and then I do the same thing. I set it to loading, and then after 2 seconds, I set the data. Now, instead of a list footer component, we would need a list header component. And then for the activity indicator, I want it to be animating if we're loading previous data. So is loading previous data, right? So with that, I believe our implementation should be done. So let's go ahead and test it. All right, so as we scroll down, which this is the functionality that we already know. Now let's go ahead and implement scrolling up. So as you can see, as I scroll up, we get more data, and it's pretty good. But to be honest, this implementation is not perfect. I'm really not happy about bidirectional and infinite lists with LegendList. Let me explain to you my issues. So first of all, when you scroll top and it loads more items, you see this flicker, right? And let's see it again. Yeah, you see this flicker, which is not a good user experience. And the other thing is that if you notice, when I get into the screen, it's not directly at the current month, even though the implementation for the initial scroll index is the same. And that's because of an issue related to LegendList. It's because it does not account for the height of the list header component. So I have this list header component, which is the loading indicator, and it's not accounting for that height when it's scrolling. And the other thing is the padding. So for the LegendList, I have this content container style with a padding. So the padding at the top is also not being accounted for when doing the scrolling. So these are two issues that I have created actually on the GitHub repo of LegendList, and I hope that Jay fixed them. I'll be leaving them in the description if you would like to check out their status. With that said, I would say that LegendList makes this implementation far easier than FlatList, and I hope that the issues are being addressed in the future. With that, we reached the end of the video. In my opinion, LegendList has great potential. The person behind it is very knowledgeable and responsive to raised issues. So while it does have some rough edges to be smoothened at the moment, I think Jay will take care of them pretty soon. I hope you enjoyed this video, and if you have any ideas for the future, please be sure to leave them in the comment section below. And until next time.